This is part 2 of the chat deep dive. And we're going to pick a Llama 3.2, a 3 billion parameter model. And the example that we're going to go through is actually how to load a table as a source, actually query a database table using natural language. So we're going to walk through 2 different examples. One really simple, just so you can get the idea of how it works, and then one a little bit more real life with a larger table. What we're going to do is we're going to load a source. The first source we're going to load is this very simple customer table. We'll call it our customer table. All right, so we've just loaded this table. So in the time that just passed, about maybe 5 seconds, we uploaded and ingested a CSV file. That CSV file had the structure of a very simple customer database table. That table was actually validated and loaded into a local SQL database. Now, there's really useful information in this source information tab. It gives you the name of the table. It tells you the file source, the rows that were created. There were 20 rows, there are 20 customers. And then the schema that was created tells you a lot of information about, in effect, what type of question you might want to be able to ask. We actually find that's a very important success factor to be successful with natural language querying of a database, is to at least have some familiarity with what's the structure of the data that's in that database and how does that data actually fit together. So now we're going to ask a simple question. You'll see I'm going to track pretty closely to that schema. All right, so we asked a question, and you can see this tracks. There were customer names, there were count numbers, there was customer level, there was annual spend. So we said, tell us which customers have an annual spend greater than 1,000, and this is what was actually retrieved from the database. Now, how did the model get this answer? Well, it actually converted that text, combined with the knowledge that it had about that data source, into a SQL query. It then queried the database, and then it retrieved this information directly from the database. So the model is not going to hallucinate or anything like that. The model is actually pulling here exactly the information that's in the database. Where things could go wrong is the model could have gotten the SQL query wrong. In case the SQL query is wrong, we may not be able to retrieve the right information from the database, but the information that we do get back from the database we know is actually coming from our own data source. Okay, so we knew that Arvind Arora was one of our customers with spend greater than 1,000. You can see in this case, we got the answer back. The spend is actually $42,650. We can ask another one of our customers, what is the customer level? So here is a good example. In a few seconds, we were able to upload a simple table. By really looking and understanding what some of the columns were in that table, here we're able to engage in some really nice natural language querying, chatting with that database table. But now you can tell this is a very, very small example. 20 rows in the database, only 6 columns. It's really designed as just a basic introduction. What if we wanted to do something with a slightly larger database table? How would that actually work? Well, first thing we did is we unloaded that source, the customer table, and now we're going to create a new source. And this time, we're going to use a slightly larger database, just so we can get a sense of how this would actually work. So we are going to pick this one. This is really our country sales data. All right, now what is happening here? So this spreadsheet was larger there were 7,600 rows with 14 different columns. We've inferred the schema, and so we're building a database schema based on the structure of the data and the patterns that we see in it. And now we're actually generating a database table. So out of those 7,600 rows, it's all being loaded into our local database. So then we can begin to start having some queries against. And again, this is a reasonable size spreadsheet. It's a little bit more real life of the kinds of data sets that you're likely to deal with. We were able to ingest it in maybe 30 seconds. And now it's going to be really important that we look at this source information. The models are not magic. And anybody that understands data knows it's actually really important to stick to the actual columns, the parameters, the features of that schema to really be able to ask questions that are ultimately going to be sensible. Let's ask a few questions, and I happen to be familiar with this data at least a little bit. So let's do all right. So across those 7,600 rows, each row represents a store. Each store is in a different city. The cities roll up to countries. And so I was curious to say, what is the total turnover by country? And then we were actually able to get the information based on our database table. It actually pulled then all the information, aggregated it. All of this was based on constructing SQL query the right way based on the question that we asked. All right, so let's see. All right, pretty cool. So you can see it actually, the query gave us back the total turnover, the revenue, and then it also actually imputed into it the opening hours. That's why we're seeing this type A. You can ask. All right, pretty cool. So hopefully this gives you an idea. It isn't going to be perfect. In fact, there's a lot of trial and error involved in this process. But what I wanted to show you was a real-life data set, how quickly it can be ingested. Now, this was a reasonably clean data. It was data that had originally come from a database, so the columns were well-defined. It didn't have a lot of missing, rows or things like that. But to take a pretty clean but real-life data set, rapidly ingest it, and then in minutes be able to start engaging in natural language around that data set. So then when we're done with this data, we can turn that source off. Now we can go back and we could have any type of chat that we would want with our model. Let's pause here, and then I'm going to come back and we're going to look at some other larger models and some more complex prompts. We can look at some higher quality generation from some of the larger models that are available in Model HQ.